Chapter 2, Section 4. In this section we're writing equations of lines, and the first equation we're going to write is the equation of the line passing through the point -3, 4 and having a slope of 2/3. Since we're given a point and a slope, we want to use the point-slope form for the equation of a line to write our equation. Now this form comes from our slope formula, because if we take our slope formula, which is the difference in y coordinates over the difference in x coordinates, and we clear this equation of denominators by multiplying both sides by that denominator, x sub 2 take away x sub 1, on the left-hand side here, that difference cancels top and bottom, and so we're left with difference in y coordinates is equal to the slope times difference in x coordinates. And that's exactly what our point-slope form for the equation of a line is. Difference in y coordinates is equal to the slope times difference in x coordinates. So in this example, our x sub 1, y sub 1 is going to be -3, 4, and our slope, or our m value, is 2/3. So writing our equation in that slope-intercept form, it would be y take away y sub 1, which is 4, is equal to the slope, which is 2/3, times x take away x sub 1, which is -3. But we would never leave our equation in slope-intercept or point-slope form. It's not an acceptable form. We'd want to leave it in slope-intercept form, so we'd want to solve for y. Okay, and to do that, first I'm going to simplify on the right by changing those double negatives inside parentheses to a positive. And then I'll add 4 to both sides and distribute on the right. So I've got 2/3 times x, which is 2/3 x, and 2/3 times 3, 3's cancel, so I'm just left with 2. And remember, I'm adding 4 from the other side. So in slope-intercept form, this equation is y equals 2/3 x plus 6. Now this is a good form to leave our equations in because it gives us a lot of information. It gives us the y-intercept and it gives us the slope. But sometimes we're asked to leave our equations in standard form. So let's just change this equation to standard form, which means our x and y terms are on the left and a constant term is on the right. So if I were going to change this slope-intercept form to standard form, I'd begin by moving the x term to the left, so subtracting 2/3 x from both sides of this equation. And then in standard form, a, b, and c are integers, a being a positive integer. So now to make sure that a, b, and c are integers, I'd multiply both sides of this equation by -3. So distributed on the left, I have -3 times -2/3 x. Well, 3's cancel, and a negative times a negative is a positive. So I get positive 2x, and -3 times y is -3y. On the right-hand side, I have 6 times -3, and that's -18. So this equation is in standard form, but the same equation in slope-intercept form looks like this, and the same equation in point-slope form looks like this. They're all the same equation, just 3 different forms. Okay, in this example we want to write an equation for the line passing through 2, -3 and perpendicular to the line y equals 2x minus 3. So since we know that the line we're writing the equation of is perpendicular to this line, y equals 2x minus 3, and we know that lines that are perpendicular have slopes that are opposite reciprocals, we can use the fact that the slope of this line is 2, and the slope of the line that we want to write the equation of is the opposite reciprocal of 2, or negative 1/2. So we'll use negative 1/2 and the point 2, negative 3 in order to write the equation of the line that's perpendicular to y equals 2x minus 3. So since we're given a point and we found a slope, we can use point-slope form again. So y take away the y coordinate of negative 3 is equal to the slope, negative 1/2, times x take away the x coordinate of 2. But again, we wouldn't leave it in this form. We'd leave our equation in slope-intercept form. So we'll distribute on the right, negative 1/2 x, and negative 1/2 times negative 2 is positive 1. And then we'll subtract that 3 from both sides. So y is equal to negative 1/2 x, and 1 minus 3 is negative 2. So this line is perpendicular to the line y equals 2x minus 3. Their slopes are opposite reciprocals. Now instead of being perpendicular, we want to maybe write the equation of the line that's parallel to y equals 2x minus 3. So then we need to know that parallel lines have the same slope. So the slope of this line again is 2. That means the equation of the line we're writing has a slope of 2 also, and it passes through the point 2, negative 3 again. So again, we have a slope and a point, so we'll use point-slope form. Y take away the y coordinate of negative 3 is equal to the slope of 2 times x take away the x coordinate of 2. And again, leaving this equation in slope-intercept form, we'll distribute on the right, so we get 2x, and 2 times negative 2 is negative 4. And again, we'll have to subtract 3 from both sides, so we get y equals 2x, and negative 4 minus 3 is negative 7. So this equation is the equation of the line parallel to the line we started with, y equals 2x minus 3. They have the same slope. Okay, in problem 2 here, we're writing an equation for the line passing through the points 1, 5 and 4, 2. To write an equation, whether it's in slope-intercept form or point-slope form, either way we need a slope. So we'll first find the slope of the line that passes through these 2 points by taking a difference in y coordinates on the top, 5 take away 2, and a difference in x coordinates on the bottom, 1 take away 4. Okay, and then simplifying, I get 3 on the top, and 1 take away 4 is negative 3 on the bottom, so that slope simplifies to negative 1. And now to write the equation, I can choose either point and use the slope, and use point-slope form to write the equation. So again, I'll take y, take away the y coordinate I chose to use, 5, is equal to the slope that we found, negative 1, times x take away the x coordinate I chose to use, 1. Okay, and again, we won't leave it in this form. We'll add 5 to both sides and we'll distribute on the right. Negative 1 times x is negative x, and negative 1 times negative 1 is positive 1. We're adding 5 from the left-hand side. So in slope-intercept form, this equation is y equals negative x plus 6. Here's an application problem. In 1991, there were 57 million cats as pets in the U.S. By 1998, this number was 61 million. Write a linear model for the number of cats as pets, and then use the model to predict the number of cats as pets in 2012. So first, I want to consider the fact that in 1991, when the study starts, time is 0. I can let t equal 0 in 1991. And in 1998 then, 7 years later, t is going to equal 7. Okay, so our ordered pairs will have time and number of cats. So I'll let C equal the number of cats in millions. Okay, so for 1991, when time is 0, the number of cats is 57 million. And in 1998, when time is 7, the number of cats is 61 million. So that gives me two ordered pairs. Now if I want to write a linear model or an equation, the first thing I'm going to have to find is the slope for that equation. So I can use these two ordered pairs, take a difference in y coordinates, 61 take away 57, or c coordinates in this case, over difference in t coordinates, 7 take away 0. So in the top I'm getting 4, and in the bottom 7. So my slope is 4/7, and then in this point I'm given the y-intercept, because when x is 0, this is the y-intercept. So I can use slope-intercept form, y equals mx plus b, to write the equation of this line, because I know the slope and I know the y-intercept. Only instead of y, we're using c, the number of cats in millions, and we found a slope of 4/7. Instead of x, we're using t for time, and our y-intercept is 57. So this is the model that we can write for the number of cats as pets in the U.S. Now we want to use the model to predict the number of cats as pets in 2012. So in 2012, which is how many years after 1991? If we subtract, we're going to find out that it's 21 years later. So we want to let t equal 21 in our model and solve for c. So of course I'm going to have to multiply before I add. 7 is going to cancel top and bottom. So I'm left with 4 times 3, or 12, plus 57. And 12 plus 57 is 69. So that tells me that the number of cats in 2012 is going to be 69 million in the U.S. So in 2012, the number of cats as pets in the U.S. is 69 million. According to this model. Included in your notes of this video, guided practice problems 5, 6, and 7 found on pages 99 and 100 of your textbook.